Arithmetic reasoning is best known as the word problem section. While many may think that word problems are easy, the arithmetic section is challenging because the test taker must read and answer a math word problem with very little time. That means that strategy and speed are important components in preparing for this portion of the ASVAB. There are 3 things we will focus on in this video. First, we will focus on understanding how to approach word problems. We will go over basic concepts that will help you answer most of the questions in this section, and we will give you strategies for preparing for this section of the ASVAB. Let's go ahead and look at how we can break down a word problem. In a store, there are 4 part-time employees and 2 full-time employees. Part-time employees earn $350 per week, and full-time employees earn $550 per week. What is the average pay of all the employees in the store? Let's go ahead and take a look at how to break down this word problem. So like I said, there are part-time employees and full-time employees. The first step we're going to do is we're going to break down the givens. We're going to list all of the givens for the word problem. So we know that there are 4 part-time employees. And we know there are 2 full-time employees. After reading the word problem, we also know that part-time employees make $350 per week, and full-time employees make $550 per week. The next thing we need to do is identify the question. The question is asking for the average pay of all of the employees. How do we find the average? Well, to find the average, we must add up everything and get a total and divide it by the number of employees there are. So, the first step in this is getting a total for the employees. First thing we did was state all the givens. Second thing we did was identify the question. Now we must figure out how we're going to answer this question. The first step is to multiply. So we'll do 350 times 4 because there are 4 part-time employees. Well, 350 times 4 times 0 is 0, 4 times 5 is 20, so we carry a 2. 4 times 3 is 12, so 12 plus 2 is 14. So the total for the part-time employees is $1,400. Next, we will multiply 550, which is the weekly pay of full-time employees, by the number of full-time employees there are. 2 times 0 is 0. 2 times 5 is 10, so we have to carry a 1. 2 times 5 is 10 again, plus 1 is 11. So the total for full-time employees is $1,100. Now, remember we said to find the average, we need to go ahead and get the total and divide it by the number of employees that there are. So we'll add up the amount that these employees make per week, and we'll divide it by the number of employees. So we have 1,400 plus 1,100, 0 plus 0 is 0, 0 plus 0 is 0, 4 plus 1 is 5, 1 plus 1 is 2. Our total is 2,500. Now let's go ahead and divide that by the number of employees that there are. There are 6 employees, and 2,500 is our total. So, 6 goes into 25 4 times. $25 minus 24 is 1. We're going to bring down a 0. 6 goes into 10 1 time. 6 times 1 is 6. 10 minus 6 is 4. We bring down the other 0. 6 goes into 40 6 times. 6 times 6 is 36. 40 minus 36 is 4. We can add a decimal, add another 0. If we added a decimal in the bottom, we must also add a decimal to the top. 6 goes into 40, 6 times again. And if we continue this problem, we'll find that the 6 is repeating, so we can stop here. We can conclude that the average pay for the employees at the shop is $417 per week. Let's go ahead and take a look at another problem. So let's go ahead and do the first step, which is stating all of the givens. Alan earns $9 for every hour. But he earns $9 for every hour the first 8 hours he works. After working 8 hours, Alan earns time and a half, which means we would have to multiply 9 hours times 1.5 because this is time and a half. It's asking us how much did he earn on Tuesday when he worked 10 hours. So we have to figure out how much he earned in the first 8 hours and then how much he earned the second 2 hours that he worked. So let's take a look at how much he earned for the first 8 hours. To find that, we will multiply $9 times 8 hours. 9 times 8 is $72. That is how much he earned the first 8 hours of work. Now we have to figure out how much Alan earns when he's working time and a half or overtime. So we do $9 times 1.5. 5 times 0 is 0. 5 times 0 is 0. 5 times 9 is 45. We add a 0 when we start with the second one. 1 times 0 is 0. 1 times 0 is 0. 1 times 9 is 9. We add this up. 4 plus 9 is 13. Then we look at how many numbers there are behind the decimal point. 1, 2, 3. That means in our answer there will be 3 numbers behind the decimal point. 1, 2, 3. Our decimal point goes right here. So Alan earns $13.50 per hour when he works overtime. Let's see how much that adds up to when it's 2 hours of overtime. $13.50 times 2. We carry the 1. 2 times 3 is 6, plus 1 is 7. 2 times 1 is 2. There are 2 numbers behind the decimal point, so there will be 2 numbers behind the decimal point in our answer. So the first 8 hours that Alan worked on Tuesday, he earned $72. The second 2 hours that Alan worked on Tuesday, he earned $27. So now we have to add those up. $72 plus $27. We line up our decimal points. 2 plus 7 is 9. 7 plus 2 is 9. Alan earned $99 when he worked 10 hours on Tuesday. Let's go ahead and take a look at the next problem. So now that we've looked at how to break down word problems, let's take a look at the types of word problems you're going to come across. One of the most common word problems that you will come across is the percent word problem. Let's take a look at first how to solve for percentages, and then we'll see how we can apply that to word problems themselves. So The easiest thing to do for word problems is use a very common equation that's easy to remember and we can apply to a lot of different things. And this consists of an actual fraction equal to a fraction. Let me explain. So, we have two fractions equal to each other. In the first one, we're going to compare the part to the whole. And in the second one, we're going to compare the percent to 100. This might not make any sense yet, but bear with me, I'll explain how this works. So the first question we're going to have is, what is 20% of 40? We're just solving for percentages now, okay? So we want to know 20% of 40. 40 is the whole. The 20 is the percent. So let's plug it into our equation. We don't know what the part is. That is what the question is asking us for. But we do know the percentage and we do know the whole. So 20% is what we're looking for, and the whole is 40. Because we don't know the part, we're going to call it x. And 100 will always go down here no matter what. Whenever we have two equations or two fractions that are equal to each other with that equal sign in between, we can always cross multiply. Cross multiply means we take this one and we multiply it to the one that's across from it. We go across the equation, across the fraction. So, x times 100 is 100x. And 40 times 20 is 800. Now that we have done that, the next step is to isolate the x. Whenever we want to solve for an unknown variable, we need to isolate it by doing the opposite of whatever is going on with it. So here, this x is multiplied to 100. If it's multiplied to 100, we must do the opposite, so we're going to divide by 100. And if we do something to one side of the equal sign, we always do it to the other side of the equal sign to make sure it's even. So this cancels out because 100 divided by 100 is 1, so we're left with just x. And 800 divided by 100 is 8. So now we know that 20% of 40 is 8. Let's look at other ways we can use this equation to solve percent word problems. Sometimes the question will not ask for the part, but it'll ask for the actual percent itself. What we do is we identify the givens, plug it into our equation, and then solve for the percentage. Let's take a look at what that can look like. So the question is, what percent is 25 of 75? 25 here is our part. 75 is the whole, and we are looking for the percent. So we can plug in all of these givens into our equation. Our equation, remember, is part over whole equals percent over 100. So, do we know the part? Yes, we know that the part is 25. Our whole is 75. And 100 always goes down here. In this situation, what we're missing is the percentage. So we're going to call that x because it is our unknown. Now, whenever we have two fractions equal to each other, we can cross multiply. So let's do that. 25 times 100 is 2,500. And 75 times x is 75x. Because the x is multiplied to the 75 and we want to isolate the x, we're going to go ahead and divide it. Whatever we do to one side of the equal sign, we do to the other side of the equal sign. So this cancels out and becomes x. 2,500 divided by 75 needs to be worked out. So 75 goes into 250 3 times. And equals 225. Let's go ahead and subtract that. we can bring down the 0. 75 goes into 250 again, 3 times. We can subtract that, and if you'll notice, it keeps repeating itself. So we know that 25 is 33% of 75. So let's take a look at another question that also looks for percentages. The question is, what percent is 30 of 120? Well, here the 30 is the part, the 120 is the whole, and once again we're looking for the percent. Let's plug that into our equation and see how it works. So like I said, the 30 is the part, 120 is the whole, and 100 always goes down here. Because we're looking for the percent, we're going to place a variable where the percentage would normally go. And like I told you before, when we have two fractions that are equal to each other, we can cross multiply them. So 30 times 100 is 3,000. And 120 times x is 120x. Now, we see here that we have a variable that's unknown and we have to isolate it to be able to solve for it. It is multiplied to the 120. Because it's multiplied to the 120, we do the opposite and we divide so we can solve for it. $120 divided by 120 gives us 1. 300 divided by 3,000 divided by 120 is a little bit different. So we can eliminate a 0 from the top and the bottom so we can use smaller numbers and it's easier to work with. So let's do 300 divided by 12. So 12 goes into 30 2 times. 12 times 2 is 24. 30 minus 24 is 6. We bring down the 0. 12 goes into 60 5 times. 12 times 5 is 60. 60 minus 60 is 0, so that means this divides perfectly. Our x is 25. Now, let's go back to the question. What was it asking for? It was asking for a percent. So, this is 25%. Okay, how are we doing? I hope you're keeping up. Let's take a look at one more way that we can use this equation to help us solve for percent word problems. So sometimes it'll give us a percent, and sometimes it'll give us the part, and then it won't give us the whole. So let's take a look at what that kind of question looks like. So the question is, 44 is 12% of what number? In this question, 44 is the part, 12 is the percent, and we are looking for the whole. Let's go ahead and plug that into our equation and see how it works out. So, like I told you, 44 is our part. We know our percent is 12. We don't know our whole, but we do know that 100 always goes down here. So like I've told you before, whenever we have two fractions that are equal to each other, we can cross multiply them. So let's go ahead and do that. So x times 12 is 12x. And 44 times 100 is 4,400. So let's go ahead and divide by 12 so that we can isolate the x. Let's go ahead and divide by 12 to be able to isolate it. When we do that, This cancels out and equals 1, and now we have to work out 4,400 divided by 12. So 12 goes into 4,400. 12 goes into 44 3 times. 12 times 3 is 36. 44 minus 36 is 8. Now we can bring down a 0. 12 goes into 80 6 times. 12 times 6 is 72. 80 minus 72 is 8. Let's bring down another one. 12 goes into 80 6 times once again. 12 times 6 is 72. 80 minus 72 is 8. We can see that this is a repeating question. We can see that this is a repeating number, so we can go ahead and stop here. That means that 366 is the whole. 44 is 12% of 366. Great, so now that we've looked at all of the ways that we can use this equation to solve for percent word problems, let's actually look at the word problems. So let's take a look at the first one. There are 250 students at a field day. 20% of the students at the field day are wearing hats. How many students are wearing hats at the field day? Let's take a look at how to break down this problem. First, let's identify what kind of question it is. How many students are wearing hats at the field day? That's what it's asking us for. The givens are that there are 250 students and that 20% of those students are wearing hats. So that means that we have to find the part. We want to find the number of students that are wearing hats that day at the field day. So the 250 is going to be our whole, the 20% is our 20%, and our unknown is going to be the part. So when we do our formula, let's go ahead and put an X for the part. Remember that our whole was 250 because there are 250 students at the field day. 20% of them are wearing hats. And if we want to know how many students there are, this is the number of people wearing hats. This is the percent of people wearing hats. If it matches up, then we're doing good. And 100 always goes down here. Now let's go ahead and cross multiply. X times 100 is 100x. 250 times 20 is 5,000. Now let's divide by 100 to isolate the x. We can eliminate the zeros that they have in common on the top and the bottom. This gives us x equals 50. That means that there are 50 people at the field day wearing hats. Let's take a look at the next problem. The next problem says, the 2000 census revealed that 62% of households in the US have more than one television. If there are 10,000 households in the town of Fellsmere, how many of those homes have more than one television? So here it gives us the percentage and it gives us the number of households. If 10,000 is the number of households, then 10,000 is the whole. And once again, we are looking for the part. Let's plug it into our equation. So the part we're going to call x because we don't know it. And the percentage is given to us by the problem, which is 62%. And we know that the whole is 10,000 households in the town of Fellsmere. And we know that 100 always goes down here. Now let's go ahead and cross multiply. X times 100 is 100x, and 10,000 times 62 is 620,000. Let's divide by 100 because 100 is multiplied to the x. When we do that, that cancels out. Whatever we do to one side of the equal sign, we must do to the other. And when we have zeros in common on the top and the bottom, we can cross those out. So there are 2 zeros down here that can be crossed out by the 2 zeros up here. We're left with 6200. X equals 6,200. Out of the households in Fellsmere, 6,200 of them have more than one television.